Today let's work on this minimum characters required to make a string palindromic together. And for this problem, let's briefly go through the problem description. We are given a string A, and we can only insert characters at the beginning of the string. We need to find how many minimum characters are needed to be inserted to make the string palindromic. For example, for ABC, we need to insert CB to make it palindromic. And we will return 2 because we insert 2 characters. And for this, we need to insert AA, and we need to return 2 because we return 2 characters. For this problem, I'd like to use a concept in the KMP algorithm. The concept is longest proper prefix. And let's firstly implement a function to get the longest proper prefix of the string. So this function will be called getLPS, and we will pass in a next array here, and we will also pass in a string as here. And how to get our next array? Well, we will firstly initialize a j equal to x, and we will also make next 0 equal to 0. And then for I in range length next, for I in range 1 to length next minus 1, while j is larger than 0 and si not equal to sj, we will update the value of j will equal to next j minus 1. And if when we go out of the while loop, if si equal to sj, j will equal, if si equal to sj, j will equal to, we will update the value of, we will update the value of j first. J will, we will add 1 to j, and after the if statement, we will update the value of next I will equal to j. And with this function, we can get a next array which stores the longest proper, which stores the length of the longest proper prefix of every character in the string A. And we need to, but we will not get the LPS of string A. Instead, we will get the LPS of string A plus a punctuation plus A minus 1, plus the reverse of A actually. And then we will get LPS of A, and the next array will be 0 times length of A, yes, length of A, yeah, and we will pass in next here, and we will return the value of length A minus. No, we will record the value of length A before making a concatenation of A and its reversal. We'll record it first, and finally we'll return a minus next minus 1. So let's run this algorithm first. That's correct. So let's explain why we will use we will concatenate the A and A punctuation and the reversal of A, and we will get the next array. That's because, let's have an example. For example, if A equal to AACE, CAAAA, and in this case, when we use this statement to update A, it will become AAAA, CECAA, and at this time, the longest proper prefix for the last position will be the length of this suffix and the length of this prefix, and the number will be 1, 2, 3, 4, 5, 6, 7. The number will be 7. So next, minus 1 will be 7. And the 7 actually represents the length of the palindromic substring in the length of the palindromic substring of string A. So 7 represents this string, the length of this string. That is because of the property of KMP algorithm. And what we need to do is to return the length of string A minus the length of its longest the length of its longest proper prefix, and that's it. So we will return 9 minus 7 equal to 2. The rationale behind this solution is a little complex, so I will not explain here. And the time complexity will be O(n), because here by making a copy, we takes O(n), and here by getting the next array, we will also take O(n). Although we have nested loop, but actually here, inside the outer loop, all of the if we add up all of the operations inside the outer loop, the operations on J will be proportional to n. So actually, this entire nested loop will take O(n) time, and and for the space complexity, it will be O(n) since we use a next array here.